So this engine was so new that we had to get an actual full vehicle to even get the engine to pull apart. It's an inline 6-cylinder engine, which is what the Supras have had for generations now, except this one's much more modern. It's kind of cool to see all the new technology that they put. Like this one, everything was really lightweight. The exhaust system, it even had oval tubing on the exhaust. Everything was quite modular and relatively easy to take off. And surprisingly, the cars actually feels simpler than some of the older ones. Somewhere a couple years ago, the cars got really complex with all the emissions control and everything, but now the engineering's gotten to the point to where they've simplified it down again in the systems. So the first thing that came up when we got the engine out was we realized we can't mount it on our normal engine stand because the timing chain that runs from the crankshaft up to the cam gears, it's actually on the back side of the engine where the transmission mounts up. And you can see here where it comes apart where the black silicone is coming out. And since we usually bolt the engine stand to where the transmission bolts up on the block, we couldn't do it this time because that cover has to come off. So we had to actually fabricate a bracket that goes from the engine stand to where the motor mount bolts up on the side of the engine block. And then once we got that set up, we realized that the engine stand was moving around quite a bit, like flexing. So then we added welds onto the engine stand where it's just bolted to try to get the engine stand more rigid, which actually worked pretty well. Once Sean and I stripped down all of the wiring and the hoses, you could actually start seeing the block, the cylinder head, and the turbocharger and everything. First thing you notice is there's only 2 exhaust ports, but it's a 6-cylinder engine. What they've done is there's actually an internal exhaust manifold, but I do like the elegance of the turbo actually bolting straight to the cylinder head. Here's the drive-by-wire throttle body, and inside is where the intercooler is. It's actually a water-to-air heat exchanger. The reason you want the intercooler is because when the turbo compresses the air and makes the boost, it actually makes the air temperature higher, and that'll make it less dense air charge. The intercooler will cool it back down before it gets into the engine. The air will be more dense, and it'll actually make more power. First thing we did is pull off the throttle body, and this is drive-by-wire. You know, modern cars don't use a throttle cable anymore that connect your foot to the throttle. It's all electronic. The speed of the electronics are actually faster than your foot can move. If you're complaining at all about the way that your drive-by-wire is running, or you don't like the response of it, it's the tune-up. It's actually not inherently a problem with drive-by-wire. Next, we'll pull off the intake manifold. You'll notice it's all plastic, and somehow they're able to manufacture this with an intercooler inside of it. You actually can't pull it apart. It's bonded together. This whole unit on the back of the block here is the thermostat housing, and it doesn't use a traditional thermostat that opens and closes with temperature. The ECU actually controls a rotary valve inside of it and can change the water flow however it's programmed, instead of it being mechanical like previous engines. Here we've got the oil filter. I really like these canister type oil filters because then you can see the actual element and anything that the filter's been picking up. So this block is the oil to water heat exchanger. And what it does is it's basically an oil cooler, and it uses the radiator coolant to keep it cool. The coolant flows through one way, the oil flows through the other. And if you look when I pour it, you'll see oil out of one point and then the green coolant out of the other one. This allows the oil to come up to temperature quicker. That actually makes the oil system simpler because you don't have external oil lines running out to some cooler on the front of the car. Once I've got the water pump and the alternator bracket off, we can move to the other side, which is the turbocharger side, exhaust side. First thing we'll do is get all the hoses off. This is the oil drain. So the turbocharger needs to be lubricated. After the oil goes through the turbo, it gets returned to the pan through this hose. Pretty simple, only 6 bolts and 1 bracket on the bottom, and the whole turbocharger system came off, and it's actually really lightweight, which is nice. And you can see heat shield on the back, and again, just the 2 exhaust ports. So this is the whole ignition system, direct coil on plug. So this is the coil, the igniter, like whatever you're used to is all in this one package. So there's just direct wiring from the ECU directly to these coil packs, and then the spark plug is down into that hole. For the direct injection, so all the fuel injectors are actually not in the ports, they go directly into the combustion chamber. This is the mechanical fuel pump. Because the direct injection runs at such high pressure, thousands of PSI, you need a mechanical fuel pump to make those pressures. So once I get the hard lines off for that, I'll pop the mechanical fuel pump off. And it's a pretty neat design. It bolts right here to this stand and the valve cover. And you can see the mechanical part where it goes up and down and pumps the fuel. Inside, which we'll get to later, you'll see a lobe on the camshaft. That is what actually pumps the pump up and down. So this is the fuel rail. This fuel rail and these injectors, where you can see the hole down in there, there's a hole for the spark plug on the bottom and the hole for the injector on the top, and both of those go directly into the cylinder. When we have the head off in a little bit, you'll be able to see those holes. Once we get the valve cover off, you can see the adjustable cam gears. So here the chain goes up to those gears, and inside those gears, the computer can control the location of that camshaft relative to the crankshaft and adjust the cam timing however the programmers program it. Then you can get the maximum fuel mileage, more torque, and actually more power. We leave this stuff when we build the race engines. Next, I'm going to pull out the spark plugs. This was, again, another challenge where the spark plug socket was actually too big. So I got myself a 14mm socket, but found that the diameter was too big to fit in there. We actually needed a thinner wall, and so I just went out to the lathe and turned it down a little bit, and we're able to get the spark plugs out. So we'll turn the engine a little bit and get to the oil pan. This car and a lot of modern cars have some sort of warning when your oil level gets low, and this is the sensor that goes into the oil pan that measures how much oil is in your engine. So once we get that sensor out, we can set that aside and then start pulling off the entire oil pan. And you'll notice it's a big aluminum oil pan. They actually don't use gaskets. There's very few gaskets on this entire engine. It just uses silicone to seal it up. So a little bit of pry bar, and we've got the oil pan off. On the way to get the camshafts out, we've got to get this whole timing chain off. So this part is the timing chain tensioner. So it keeps the right amount of tension on that chain. Once we get that off, then we'll pull the timing cover off. And remember, this is the back of the engine where the transmission bolts up. Normally, all this timing chain stuff is on the front where the pulley is. So I'll go over where the pulley is, turn it, and now you can see how the crankshaft turns down there at the bottom. There's a chain that comes up to the top to turn both camshafts. And that secondary chain way at the bottom turns the oil pump. After we get the timing guides off, I can set the timing chain aside and we can start pulling the camshafts out. But before we do that, I'm going to describe what you're seeing here with the valve train. So this is a dual overhead cam engine, which means it has two cams, and they push down on the valves with these rocker arms. Relatively typical. So the exhaust is on the left, the intake cams are on the right, and the exhaust is relatively straightforward. The cam lobe turns, it pushes on that roller on the rocker then pushes down on the valve and opens the valve. The valve spring is what's used to push it back up again. The intake side is actually way more complex. It's variable lift camshaft setup. And it still uses a camshaft, but there's two separate rocker arms, and it has an eccentric shaft that changes the rocker ratio. So you can mechanically do it. Typically, the computer controls this. Depending on the throttle position and the load and how they program it, it'll have a different amount of camshaft lift. When I turn it, you can see this eccentric shaft moving that upper rocker, and it changes the ratio. And now when the camshaft moves, it pushes that first rocker, that then pushes the second rocker down there, and then eventually pushes down and opens up the intake valve. First, I'll pull out the exhaust cam, we'll pop off the exhaust caps, and this is the mechanical fuel pump stand. You can see all the cam lobes, and this one's a little bit different. It's got three sides to it. That's the lobe that pushes on the mechanical fuel pump, and it pumps 3 times every time that camshaft turns. Pop the exhaust cam out, set that aside. The rocker arms just sit in there under the camshaft, and they pivot on this, what they call a lifter. It's a hydraulic lifter, so these kind of engines never need a valve adjustment. And one thing I really do like is these rockers have this small little spring clip, and it keeps the rocker from falling off the lifter. If there's like valve float or something like that at really high RPM, some of the other engines that we've worked with in the past, we've had problems with rocker arms falling off with racing, but this should hopefully solve that issue. On the intake cam side, there's actually a special tool that you need to pull these springs off that I don't have. So now we're improvising. Typically you wouldn't want to get in there with a pry bar. I'm being as careful as I can be. And it's kicking my ass. So what I decided to do was get the spring unloaded as much as I could, lean on it with the pig mat so nothing pops up at me. I got my safety glasses on, and just slowly pull the camshaft out and let the springs uncompress. I wouldn't recommend doing this, but you know, it's for you guys, man. I gotta get this video done. Can't wait for tools to come in. I'll definitely need the tool though when reassembling it. Once the cam caps are all off, and I made sure that I didn't hurt myself and I didn't lose any parts, we can get the intake cam off. And this is the eccentric shaft that adjusts the rocker arm ratio. Now that we've got the cylinder head all stripped down, you can see all of the components that there are. And I've laid them all out in order where they came off. That way, when they go back together, they can go back in the same location they came from. Now we have access to the cylinder head bolts. These are a relatively straightforward T60 Torx drive. And I get in there with my big breaker bar, because these are always torqued really high. Brace myself against the engine stand, and then I'll turn them a quarter turn first, just to get them a little bit loose, and then I'll get the gun and just zap them all the way out. And now I'm just peeking under to make sure I didn't forget anything. I don't know, I've never pulled the head off one of these before, so I'm always trying to look around and make sure I didn't forget anything or miss anything. Now we can see all 6 cylinders and the head gasket. The orange that you're seeing is the sealant. It's a coating that they put on there to make sure that none of the water or the oil ports leak out. Now that the cylinder head's off, you can see in the combustion chamber, the 2 lighter colored valves are the intake valves and the black valves are the exhaust valves. You can see the threaded hole is where the spark plug goes, and the hole right next to it is where the fuel injector inserts. It injects the fuel directly into the chamber right there. The first thing I noticed when I got the head off now is that it's a solid deck block. I mean, you see holes for the water and stuff, but it's not an open water jacket. And these are much stronger. So I believe that this engine has tons of potential. Now let's flip the engine over and we can start pulling the short block apart. This bolt is actually reverse rotation. I have been reading the service manual on this, and this is one of the reasons why I always want to read the manual if it's available, because a bolt like this can really give you a bad day if you don't realize it's reverse rotation and you keep turning it counterclockwise to try to loosen it and you end up breaking it or something. I knew ahead of time, turned it clockwise, came right out, moved on to the next thing. So this is the combination windage tray and block girdle. So it actually is pretty heavy. It's a couple pounds and it's thick. It ties in all of the crankshaft main caps and the skirts on the block. And what's great about that is it makes the block a lot more rigid. Another thing that's really interesting about this engine, there's no center crank pulley bolt. It's like a flange type pulley. So it has these 4 bolts, and in order to turn it, you have to get this special socket. And there was easy to get. This was $60. Another thing about this block that I really like is the oiling system. You know, there's a bunch of oil that goes up to the head, and it has to get back into the oil pan. So the way that they design these is they don't want that oil to end up on the crankshaft and create a bunch of windage. So it actually comes down the side ports and ends up underneath the windage tray and straight into the pan. So that way the crankshaft, not splashing through any oil in the pan and creating windage and drag. And if you look down there, you can see the oil squirter. That little squirter pushes high pressure oil on the bottom of the piston, and it keeps the piston cool and actually helps lubricate the cylinder wall as well. Another thing I like to do is see if I can turn the engine short block by hand. And actually this was really easy to turn, which means it has really low friction rings in it, which is good for high horsepower and efficiency. So after I got the connecting rod cap off, I noticed a couple of things right away. Number one is it's got a cracked rod cap. Now that sounds like something's broken, but it's actually a design. We'll get to that in a minute when we start talking about the rods. The other thing is it also has a coated rod bearing. So I guess with all the automatic engine start stop function stuff, you know, when you go to the stoplight and the engine shuts off and it turns back on again, it can start wearing out the bearings a lot quicker. So they have these coated bearings, so there is no issue with that. Once I got the piston and rod out, we can get a closer look at what's going on with this rod design. And if you look at it real close, see how it's all porous and all this weird shape? And from what I've seen, the way that they crack the rods is they get in there with the laser and they scribe a line on the inside of the bore, and there's a machine that comes down and splits the rod in two. And then what ends up happening is when you bolt it back together, it bolts exactly back in the same place every time, and they don't have to machine all of the surfaces. The piston's really modern also. You can see where it's pocketed to reduce weight. It uses a full floating pin, and it's got some coating on it on the skirt. This is a forged steel crankshaft, which looks relatively stout. So we're gonna start with this. I think this will definitely hold at least 1,000 horsepower. Now when it was time to pull the pulley off, I was like, okay, that didn't feel too safe. So I got Matt to come help me out. We put a couple of bolts in the back of the crankshaft there so it wouldn't spin, and then I was able to loosen all of the bolts that hold the pulley on. Once I got the pulley off, you can see how it's just a flange. There's no actual snout anymore on the crank. And what's also trick is the block. It has like this deep skirt, and it just straight up has a hole in the side of it with the front main seal on it. So I'll go ahead and loosen all the main cap bolts, zap them all out with the gun, and then I can start pulling the crankshaft out. This definitely looks like a solid race block. One of the big questions is this a worthy successor to the 2JZ engine? Time will tell. And did Toyota get it right by partnering with BMW with this whole project? So far, I'm pretty impressed.